Alright, so in this video we're gonna go through some revision notes for Physics 0625 Cambridge IGCSE for topic 6, energy stores and transfers. So just as I said, energy stores and transfers, the first thing I said was energy. Energy, we hear this term a lot in our daily lives, like more than 50 times a day we're using the term energy. We read it so much, we're like, energy is everywhere, okay? But what do we really mean by energy? What are the different forms of energy? How does energy exist in our natural life? How does it affect our natural phenomenon? And what is the science behind energy? What does it really mean? And how can you apply it everywhere in life after you understand what it really means? Energy is simply, as the definition in physics says, is the ability to do work. So when we say the ability to do work, it means the ability to make a change. Make a change in an object, in space, in matter, but a change of distance per unit time. So that's why we say it's the ability to do work. It's the ability to make change on a distance, on anything, matter, air, space, particles, okay, but on their distance per unit time. And this is why energy is a scalar quantity, because it's the ability to do work. All right, the SI unit of energy is joules. So energy is measured in joules. It's a scalar quantity. Now we know that energy is the ability to do work. We don't do energy. Energy is already stored in objects. What we do is we transfer energy from one object to another, from humans to other humans, from humans to objects, and etc. So energy stores is the energy stored in object. Let's see what are some common energy stores and where they are stored and how they are used. The first one is our kinetic energy store. So moving objects have energy in their kinetic store, because all kinetic energy is the energy of motion, so all objects that are moving have energy in the kinetic energy store. Gravitational is when objects gain energy in their gravitational potential store, they are lifted above the ground. So the higher you go, because gravity is the pull or force that pulls you down perpendicular to the position on Earth towards the center, right? So the farther away you go from the center of Earth, the farther away you go from Earth, the more gravitational pull there is upon you. Then we have elastic, which is when objects have energy in their elastic potential store when they are stretched. So just when you're stretching, you have elastic energy. Electrostatic is objects with charges like electrons and protons. They have electrostatic energy. Then we have magnetic, chemical, and nuclear, and thermal. Magnetic is between magnets. Chemical is usually between their chemical bonds. Nuclear is in the atomic nuclei, and thermal is energy in all objects in the thermal store, usually in radiation. In our syllabus, the most important ones are the kinetic and the gravitational potential energy store, because we're going to be doing calculations and etc. regarding those. As for the other energies, just memorize them, but they're not so important for our syllabus. So those are the energy stores, different types of energy stores in different objects. Coming to energy transfers, energy is transferred between stores, okay, in different energy pathways. These stores can be mechanical, electrical, heating, and radiation. So by mechanical working, when a force acts on objects, for example, pulling and pushing, you're mechanically doing some sort of work to put a force on an object and transfer energy. Electrical working is like a charge or current moves through a potential difference, and this causes or moves energy. Heating by particles. Energy is transferred from a hotter to a colder one, usually in conduction or convection, where energy is transferred from a hot to a cold object. Heating by radiation. Energy is transferred by electromagnetic waves. So electromagnetic transverse waves transfer energy through radiation or other forms of electromagnetic waves. Actually, all waves in the electromagnetic spectrum including microwave, radio wave, with visible light, gamma rays, X-rays. They all transfer energy as transverse waves. So coming to the main energies in our syllabus, we have the first one, kinetic energy. This is energy given to an object due to its motion. Any object in motion has kinetic energy or stores kinetic energy in KE store. The formula of kinetic energy is equal to half mass mv squared. This means half times the object's mass multiplied by the speed of the object squared. So half mv squared. Kinetic energy is measured in joules, the mass in kilograms, speed in meter per second. So by symbol is equal to half mv squared. Mass is equal to 2ke over v squared. And your speed is equal to 2ke over m complete root. The kinetic energy is directly proportional to the mass and speed of the object. If you increase the mass of an object, the object has more kinetic energy, and of course if you increase the speed of an object, the object has more kinetic energy, because as you're increasing the speed, you're moving faster, and the more motion you have, the more kinetic energy, as kinetic energy is the energy due to an object's motion. Gravitational potential energy, or GPE in short, in the other hand, is energy given to an object due to its height in the gravitational field. So the more it's lifted higher, as energy is transferred to its gravitational energy store, and it has more GPE. The more it's lifted downwards or pushed downwards, this GPE decreases. The formula of GPE is GPE is equal to mgh, mass times gravitational field times height. Gravitational field is a constant of approximately 10 Newton. Mass is in kilogram and height is in meters. So GPE is also directly proportional to an object's mass and height. So those are the main common energies in our syllabus. Now we're just going to name some other common types of energies, like the nuclear energy, which is the energy stored in the nucleus of an atom. Usually the all radioactive materials store nuclear energy. We have strain and elastic energy. This one is stored in the changed shape of an object due to stretching or compression, usually in strings. Thermal energy is the energy from a hotter to a colder place due to a temperature difference between them. This is usually caused by radiation, convection, or conduction. And internal energy. This is the total kinetic and potential energies of an object. And last but not least, chemical energy, which is the energy stored in the bonds. So from all these energies we just listed, they can be divided into two further groups. The first one is energies to stay, like GPE, kinetic, chemical, internal, and nuclear. Or energies to move, light, sound, heat, thermal, electric. And that's all for the energies. Coming to the principle of conservation of energy, which states that energy cannot be created or destroyed, it can only be changed or transferred from one form to another. So energy is always conserved. It cannot be changed, it cannot be destroyed. It's always there. It can only change its state from one form to another. Common energy conversions is usually when an object is falling in air, is transferring its store from its GPE to kinetic, or in a radio, electrical to sound and heat. Now to represent all of these energy changes, energy stores, efficiencies, it's going to be very difficult, so we have Sankey diagrams to help us with that. Sankey diagrams are diagrams that use splitting arrows to show the proportions of energy transfers taking place. So we usually have two splitting arrows. The first one is pointing right and straight. This represents the useful energy output. The second one is usually bent downwards, and it's an arrow that represents the wasted energy. And the width of each arrow is directly proportional to the energy being transferred. So the wider arrow means that there's more energy transfer. So for example, having a look at the first graph, the straight arrow is quite narrow, but the other two arrows are quite thick. This means more energy was lost and wasted in output than that was put into as a useful energy output. And that is also pretty much it for this